So let's do some hands-on. We have already dropped the database 3IAM Athena DB GDC. Now we're going to use only Athena SQL. So we'll create the database 3IAM Athena DB. We'll create tables for customers and we'll use Surday for CSV. In order items, we'll use Surday for CSV again. For orders, we'll use Surday for Parquet, and I have put Parquet files in the Athena dataset folder. You can download it in Parquet format. Then for sellers, we'll use Surday for Avro. Again, I have provided Avro files for the sellers table. Then we'll run some complex queries to join order, seller, order items and customers tables, just to show you that you can use these various file formats also, and Athena can join across these different file formats. And then finally, we'll use create table as to change the file format. What I have done is that I have moved all the files to their corresponding folders. For example, this customers folder contains the customers file, and order items contains the order items file, so on and so forth. So there are various files here. This is my Glue data catalog, just to show you that there are no databases in Glue data catalog, only the default database. Same, and this is the Athena dashboard, and as you can see, the data source is AWS data catalog, and I do not have any database other than default. And the first thing that I'm going to do is that create a database. And this is the database that we are going to create, 3IAM Athena DB. Now if I execute this, it has been completed. Now if you see, the database has come here, which is actually pointing to Glue data catalog. Now if I go to Glue data catalog and do a refresh, I should be able to see the 3IAM Athena database here also. Now currently this database does not have any tables because we have not created any table in Athena. And I'm creating this external table. Name of the table is customers, followed by all the data types, and all of them are strings, by the way. Now if you see, I'm using row format delimited, fields terminated by comma, lines terminated by new line, and stored as text file, and this is the location. So what will happen behind the scenes is that this particular statements would convert it to a CSV file, and the Surday that will be used is CSV Surday. Now let me execute this. So as you can see, I have got this error, line 1:1 mismatched input, so on and so forth. So it might create confusion that what happened, why it got errored out. So basically everything is fine, the entire syntax is fine, but here I'm using the date of birth as timestamps, but I'll have to use string. And now it has been completed. Now the reason it is string, it is not timestamp, because in CSV format, if you see the actual file, if you download the actual file, you can see that it is actually in double quotes. So that's why it is being considered as string, not as timestamp. And now I can see the table here, customers, and I should be able to see in the Glue data catalog also. So if you see, the customers table has been created, and this is the location that we have provided. So this is how you know that, okay, Glue and Athena are connected to each other. So this is done. So let me just run a query. I'll open a new editor. Select star from customers, limit 10. Let's see whether you can get any output or not. And there you go, we can see the output here. Only 10 records as usual. Now the next one is that we'll be creating using Surday. So I'll be creating the order items table, and this is the SQL statement. I have order ID and product ID. This is where the change is. The row format is not delimited anymore. I'm mentioning the row format is OpenCSV Surday with Surday properties. Now what are the properties? Because it is in CSV, I'll have to mention columns delimited by and the lines delimited by. So this is a separator character between multiple columns, which is comma, and this is actually new line in Athena syntax. Also, I'm mentioning something called table properties because I want to skip the first line, which is a header. So if I execute this, it should execute properly, and it is done. The order items table has been created, as you can see here, And now I can query this table in the editor and I should be able to see the output. So what I have done so far, I have created CSV file, one without using row format Serde and the second one using the row format Serde syntax. And now I'll go ahead and create the orders table, which is stored in Parquet format, and this is the location. So orders underscore Parquet. Now if I select orders underscore Parquet, you'll see that there are various files and there are a lot of files here and the type is Parquet. These are all in binary. You can download all these files and upload in your S3 folder and then try it out. All right, so what is the difference? The row format is not OpenCSV anymore. It is Parquet Hive Serde. This is the location and this is the table properties, and I'm mentioning a compression format which is snappy. Now remember, I'm not using the stored as here. If I wanted, I could have, but I'm not using it. Let me execute and it has been completed. If I query, I should be able to see the records here. And as usual, I can see the records which are there in the orders table. Similarly, I'm creating the sellers file which is stored in Avro. So now here I'm mentioning both row format Serde and stored as. So if you see, the row format is Avro Serde and I am also mentioning stored as Avro, and this is the location. The table has also been created and let me execute some query on this particular table. So as you can see, there are records visible. Right, so we have created 4 tables with different Serde formats. What we did was that the first one was CSV and I did not mention Serde. The second one was CSV and I did mention Serde there. For orders and sellers, I had mentioned Serde with Avro Serde and Parquet Serde. Now let me show you that only using stored as you can create the tables also. You do not have to mention row format Serde, because as I said, what if there's a typo while typing or while copying, you do not copy the complete line. So you might get certain error that can confuse you. So the best way is to just use stored as Parquet, and the file has to be in proper Parquet format. So I'm just mentioning stored as Parquet. The compression format is also not needed. Now it has been executed and let's see whether we can see the records or not. And if I execute, as usual, I can see the record. So here I did not have to mention any row format Serde or Serde properties, etc. And same is the case with Avro also. Just mention stored as Avro without any row format Serde. It has been completed and let me execute the command also. And as usual, you can see the records. So I'll go ahead and delete these tables. These are not needed actually. So I'm dropping sellers underscore Avro and I'll also drop orders underscore Parquet. Okay, so both are done, both the tables are done. Now let me go ahead and run some complex queries. So this is the query. I'm joining 3 tables: orders, customers and sellers. Customers is in CSV, orders is in Parquet and sellers is in Avro file format. So let me execute this query. It might take some time for the query to get executed. And here it will show us the time in queue, the runtime and the total data scanned. So if you see, approximately 20 GB of data has been scanned and there is no output, which is fine. It might be the case that because of the string data type it is not matching, but it scanned approximately 21 GB of data and took approximately 10.5 seconds and 74 ms was in queue. So it is pretty impressive because 21 GB in 10 seconds is pretty good. Now there's a reason that it ran so fast, which we'll discuss in the performance tuning section. Now what we'll do is we will create tables using CTAS or create table as, but the target table would have a different file format. So what am I doing here is that I'm creating this table customers underscore JSON, and then I'm using this with keyword, and after that we are using as select star from customers. So if I remove this with statement or with expression, it is similar to normal CTAS. Create table customers underscore JSON as select star from customers. But in with, we are mentioning what would be the external location, meaning where the data would be stored in S3, because Athena does not have any storage on its own. It has to rely on S3. So that's why the external location is S3, and what format we want to run it in, and do we want to compress it. Then if I execute it, what will happen is Athena internally would run some code and execute it. Again, it is a query engine, so it will run some code internally and then copy the records from customers to customers underscore JSON table. But in customers underscore JSON table, it will be stored as JSON data. So let me execute this. So total data scanned was 5.55 GB and the runtime was approximately 10 seconds. And this JSON's table has been created. If you see here, this is the table customers underscore JSON, and in the bucket or in the folder Athena underscore tables, I should see customers underscore JSON getting created. So if I refresh it, as you can see, customers underscore JSON has been created. And now if I click on this, these are the JSON files which are compressed using Snappy compression format. Similarly, you will do the same for orders, but we are going to create orders underscore ORC table, and the format would be ORC, and this is the external location. So now what will happen is that I'll have a file, or basically I'll have multiple files, and the format of the files would be ORC. So let's execute this, and I think it might take a little bit more time because the orders table is pretty big. Seems like it wasn't that big. I forgot that it's a smaller data set. So total data scanned was 4 GB and it took approximately 19 seconds. And orders underscore ORC has been created with the same columns and data types as that of the source table, which is orders. All are string and all are string here. And here I should be able to see orders underscore ORC getting created if I refresh. So as you can see, orders underscore ORC has been created and these are all ORC files. Now why there are so many files, I'm not going into the details of that, but the files have been created. So this is how you can use CTAS to convert from one file format to another file format also. So that's all about this topic. Let's move on to the next one.